back into Spring in Math 8. I'm Mr. Burns. Today's lesson topic, integer exponents. Let's go ahead and get started. Before we jump into our lesson, it's important to review what exponents really are. So, in my example here, we have 5 raised to the third power, or another way to say that is 5 cubed. And the large number, the 5, is called the base, and the small number above the large number is called the exponent. In this case, it's the 3. Now, 5 raised to the third power is not 5 times 3. It actually means 5 times 5 times 5. So when I work out 5 times 5 times 5, I actually get 5 times 5, which is 25, and 25 times 5 leaves me with 125. So in this case, in our example, 5 raised to the third power, or 5 cubed, is 125. Let's get started looking at some rules of exponents. So first rule we're going to talk about, power of the quotient rule. Now I know this is a huge graphic and it looks very confusing and daunting, but we're going to break it down in a simple way that will help you understand. Highlighted in yellow is our actual problem. We have x raised to the third power over y squared, and that whole thing is wrapped in parentheses, and then that entire question is raised to the fourth power. So let's break it down. We have x cubed to the fourth power. So we actually need to multiply our two exponents. In this case, we get 3 times 4 is 12. So I'm going to give out 4 different x raised to the third power here. Now we also can't forget about our denominator, y squared raised to the fourth power. And again, I broke it out 4 different times for you. And to break it down even further, 3 times 4 gives us 12 x's. So if you count our groups of x's here, we actually have 12 total. And again, on the bottom for the y's, we have 8 total because 4 times 2 is 8. So my answer to the question x cubed over y squared, and the whole thing raised to the fourth power is x raised to the 12th over y to the 8th. You should notice that we've multiplied the exponent on the outside of the parentheses by both exponents on the inside, the numerator and the denominator. Let's take a look at this expression. We have 4 raised to the 5th power over 4 squared. Now, we have that division bar, and when we see that division bar, or that fraction bar, we have that fraction bar, we want to make sure we know that it means to divide. And when we divide, we're actually doing repeated subtraction. So let's subtract our exponents. 5 minus 2 gives us 3, and we keep it as an exponent. So now our new expression says 4 raised to the third power. Now again, 4 raised to the third power, or 4 cubed, does not mean 4 times 3. It actually means 4 times 4 times 4. And 4 times 4 times 4 gives us a final answer of 64. So when you have an expression that has a base and an exponent over another base and an exponent, that fraction bar tells you need to subtract your exponents and then simplify from there. Let's take a look at this example. We have 5 raised to the third power over 5 to the 7th. So we're going to write this in another way. Let me get my pen on here. There we go. 5 times 5 times 5. Now I put 3 5s here because I have 5 raised to the third power. And then I need to make sure to draw that fraction bar. And we have 5 raised to the 7th power. So on the bottom, I'm going to write out 5 times 5 7 times. So stick with me. That's 3, 4 5s, 5 5s, 6 5s, and our 7 5. So I'm going to use some cancellation technique to help me solve this problem. I'm going to cancel these 5s because they're sitting on top of each other. Now what's left, I can continue my fraction bar here, and I can put a 1 on top. Now 5 times 5 times 5 times 5 is really looking like this. 1 over 5 raised to that fourth power here. And when I reduce that even further, I actually get 625. So my actual answer for this question is 1 over 625. Okay, let's look at another one. Simplify this expression. We have inside our parentheses, we have 3 raised to the fourth power. And on the bottom, we have 5 raised to the second power. And the whole thing is wrapped in parentheses and being squared, or raised to the second power. Now, like we talked about previously, we need to multiply or use the distributive property with that exponent on the outside of the parentheses to multiply the things that are on the inside. So you can see here that I have 3 raised to the 8th power over 5 raised to the 4th power. This is because 4 times 2 is 8, and 2 times 2 is 4. And I've broken it down for you and shown you the long way. I have 3 times 3 listed 8 times over 5 times 4 listed 4 times. In this case, our final answer is 6,561 over 625. So we can say with confidence that 3 raised to the 4th over 5 squared, wrapped in parentheses, and raised to the 2nd power, or being squared, is equivalent or equal to 6,561 over 625. Okay, let's check out this one. This looks very complicated, but we're going to go run through it and you'll have a clear understanding. I'm actually going to highlight in yellow here our actual problem. Okay, we have x squared in parentheses being squared, and then we're even multiplying that again by x to the 6th over x to the 4th. So let's take care of the first part of the problem first and use that quotient of power rule. X squared being raised to the 2nd power gives us x to the 4th. Okay? And basically, guys, I just brought down the rest of my equation. So let's tackle the part now that we haven't done yet. We have x to the 4th over x to the 6th. And we have that fraction bar down there in between them. So if we remember from earlier, we talked about how you subtract your exponents. So I brought down my x to the 4th, because I'm not doing anything with it in this particular line, and I'm subtracting 6 minus 4, and that gives me x squared. So far we have x to the 4th times x to the 2nd. And we're just going to add our exponents together, and we're going to get a final answer of x to the 6th. All right? That's it for today, guys. Hope you had fun. Good luck solving.